Last year, I made this video about 3D perspective projection and some of you wanted an update to that project. So I've been working on it for the past weeks and made some progress. But the more I progressed with it, the more I realized how much I was really limited with the decision I made early on, which was to draw and project objects per vertices. And obviously, I could just go back and make a couple of changes in my old code to fix it, but I simply just hate refactoring and looking at my old code. So I did what any reasonable programmer would have done and restarted the project from scratch. The first thing I did was to actually support triangles instead of just drawing a single vertex at a time. I got the perspective and projection to work properly. I added some transformation matrices, rotation, scaling, translation, shearing, and so on. I also added this time some sort of a Z buffer by using the normals of each face of a triangle. Well, a normal is a vector that is perpendicular to another surface. For example, if you have a vector A and a vector B, its normal vector is going to be this vector n. And to get this vector n, we are going to use a vector operation known as cross product. The trick that we're gonna use to draw only visible triangles is that we are going to draw only triangles with normals of a negative z coordinate. And this will not work quite yet because we are not taking the camera position into consideration. Well, I kinda stumbled here for quite some time, but I came across one encoder series who explained this topic properly. So this was the problem. Let's say we have our camera and an object in the scene. If we calculate their normals and we know that we only want to draw triangles with a normal of a negative z coordinate, we are going to realize that there are some particular cases where we should not see some normals with a negative z. The way around this issue is just to check in this particular case if the angle is smaller than 90 degrees, then we can draw that triangle, and if not, then we will not draw that triangle. But obviously it is not that simple to do in 3D, so for that we are gonna use another vector operation known as the dot product, which is just an operation that takes two vectors as inputs and returns a scalar number as outputs. The number returned is dependent on the magnitude of both vectors and on the angle between them. Now, as you can see, our z buffer is working properly. Since we already have our normal vectors, to compute the directional light in a scene gonna be really easy, since what you only have to do is to decide how bright a triangle is based on the angle between the triangle and the directional lights. Now our scene looks much better. Unfortunately, this directional light is not as accurate as in most game engines, simply because I don't have a way to use a fragment shader in pygame without using some other APIs like OpenGL. I also added a way to visualize our normals. With that finally done, I went and implemented support for 3D object file, so I wrote a function to load obj files. The way obj files are formatted is like this. All the vertices coordinates start with V and the face indices start with F. It also has some UV coordinates and textures and vertex normals that we don't need. Its implementation code looks like this. I know the code is really messy, but it works. There's just one thing bothering me, which was that if I wanted the 3D sphere in our scene, I had to go make one in an actual 3D software like Blender and then import it in our project. And the issue with this is that I don't have the control of the level of details of each sphere. And the solution for that is to generate my own sphere triangles. Spheres are one of the most basic geometry shapes we can think of. However, there are a variety of methods for generating surface meshes of a sphere. The most popular are UV sphere, icosphere, quad sphere, and Fibonacci sphere. For me, I'm only interested in two of them for now, the UV sphere and the icosphere. The UV sphere, which can be considered as the standard sphere, this method divides the sphere using meridians and parallels, so basically like longitude and latitude. It produces faces with bigger area near the equator and smaller ones close to the poles. The implementation code for this looks like this. And as you can see, now I have a control to the level of details I want the sphere to have. And the icosphere or the icosahedron is a polyhedron composed of 20 identical equilateral triangles and possesses some interesting properties. Each triangle has the same area and each vertex is at the same distance from all its neighbors. To get a higher number of triangles, we need to subdivide each triangle into 4 triangles by creating a new vertex at the middle point of each edge, which is then normalized to make it lie in the sphere surface. Sadly, this breaks the initial properties of the icosahedron. The triangles are not equilateral anymore, and neither the area nor the distance between adjacent vertices is the same across the mesh. Another problem with this method is that we can only increase the number of faces by 4 each time, but it's still a better approximation by almost any measure excluding its number of triangles. The only thing left to solve was this annoying frame drop when an object went off screen, and the solution for that was just to implement the clipping of triangles. I stumbled a little bit, but I managed to get it to work. And with that, I'm done for now. I'm gonna leave the GitHub link in the description if you want to check it out. It's open source, since I don't think that I'll be working on it anytime soon. There is still some problem of optimization and a few other. To improve the performance, I guess, you can use some NumPy and C function that will make it much faster. For the neural network video, I was about to upload it, but it was just too long and decided that I'm gonna make a series on it next month along with the genetic algorithm. But I'm gonna leave the link in the description for the neural network projects for those who will not wait till next month. And yeah, that's gonna be it. Thanks for watching the video. Don't forget to like and subscribe to not miss any upcoming video.